Many individuals think that fat makes you fat, returning to a metabolism myth that was debunked early in the semester. Although it can be argued that excess consumption of any macronutrient can be detrimental to overall health status, it is more important to be aware of the quality as opposed to the quantity. The food matrix is defined by the United States Department of Agriculture as the nutrient and non-nutrient components of foods and their molecular relationships. The food matrix directly affects the body's processes of digestion and absorption dependent upon the source. For example, saturated fat and unsaturated fat each have different effects on the body. The food matrix supports the fact that different fats are metabolized differently in the body, and different fat sources are deemed as healthier. Saturated fats contain the maximum possible number of hydrogen atoms bonded to each carbon in the molecule. Saturated fat is often consumed in excess of the dietary guidelines for Americans of less than 10% of total energy intake. This excess consumption of saturated fat significantly increases the risk for cardiovascular disease through abnormalities in plasma lipid profiles, specifically increases in low-density lipoprotein or LDL levels. Animal studies have shown that saturated fats increase LDL cholesterol by inhibiting LDL receptor activity and enhancing apolipoprotein B containing lipoprotein production. The LDL receptor pathway is crucial in the regulation of plasma and intracellular cholesterol homeostasis. As shown in this image, it is illustrated how a diet high in saturated fat can result in dysregulation of this pathway, leading to fewer, weaker LDL receptors, which can in turn result in a buildup of cholesterol in the arteries, further increasing the risk for cardiovascular disease. This LDL cholesterol raising effect of saturated fatty acids has been shown to depend on the level of dietary cholesterol. For example, the greatest increases in plasma LDL concentrations are observed in conjunction with higher levels of dietary cholesterol. Due to this ability for saturated fats to raise LDL cholesterol in the presence of increased intake of dietary cholesterol, there appears to be considerable inter-individual variation. Other differences in lipid metabolism may be due to predetermined genetic factors, such as the presence of apolipoprotein E gene or ApoE4. This gene, commonly associated with the development of dementia, is also connected with a greater LDL response to saturated fat intake. Trans fats are used primarily for their desired taste and extended shelf life. A majority of trans fatty acids in the diet are industrially produced through the process of hydrogenation. In the process of hydrogenation, hydrogen is added to vegetable oil to transform it into a solid fat at room temperature and make it more resistant to chemical change. Trans fats raise low-density lipoprotein levels and decrease high-density lipoprotein levels, further increasing the risk for cardiovascular disease. Other observed effects of trans fatty acid consumption include dysregulation of processes such as lipid metabolism, inflammation, and oxidative stress. Regarding the inflammatory response, dietary trans fatty acids appear to be pro-inflammatory and are associated with increases in the inflammatory markers interleukin-6 and C-reactive protein. Additionally, trans fatty acid consumption can lead to oxidative stress by the upregulation of nicotinamide adenine dinucleotide phosphate oxidase, also known as NADPH oxidase, and inflammatory cytokines in smooth muscle cells. As seen in this image, trans fatty acid consumption leads to an increase in reactive oxygen species and further oxidative stress, which is a key component in the pathophysiology of chronic disease development. Additionally, it is illustrated here how trans fats can lead to an increase in inflammatory markers such as interleukin-6. Unsaturated fats, fats consisting of only one double bond in the fatty acid or acyl group, are considered to have neutral effects in the risk of cardiovascular disease. Polyunsaturated fats include omega-3 and omega-6, which are further broken down into DHA and EPA and arachidonic acid. Omega-3 fatty acids are anti-inflammatory, antiarrhythmic, and antithrombotic. Omega-3 fatty acids have antiarrhythmic effects through stabilizing the electrical activity of cardiac myocytes, resulting in a prolonged refractory period. Additionally, omega-3s demonstrate thrombotic properties through EPA, which is shown to inhibit the synthesis of thromboxane A2, a prostaglandin that causes platelet aggregation and vasoconstriction. Both omega 3 and omega 6 are associated with a decreased risk for the development of cardiovascular disease. It is recommended that saturated fat should in part be replaced by polyunsaturated fat. Replacement of dietary saturated fatty acids with mixtures of omega 3 and omega 6 rich foods, along with dietary sources of DHA and EPA, align with the previous dietary guidelines for Americans published in 2015 and the American Heart Association. As excess omega 6 consumption has been associated with low grade inflammation, oxidative stress, endothelial dysfunction, and atherosclerosis, there should be an appropriate 4-to-1 ratio balance between omega 3 and omega 6, respectively. As a future healthcare professional, the importance of fat sources should be discussed with each patient, as the myth that fat makes you fat is not accurate. Rather, it is the quality of the fat source that determines the impact on the body, as outlined by the food matrix.